Good afternoon. This is Professor David J. De Los Reyes. This is a long-form video. This is a topic on differential equation, and this is lesson number 37. Okay, let's proceed, guys. This is now lesson number 37 on my course differential equation. This is lesson number DE37, DE meaning differential equation. So if you are following my channel, there's a numbering on the topics, okay? So actually under the topic differential equation, this is now topic number 37. It's in sequence. Lesson number 37 is actually second order differential equation. This will now be example number 1. Lesson number 36, I discussed the concepts and the solutions on how to attack a second order differential equation. Okay, let's proceed with example number 1. The best way to illustrate the concept of differential equation is by giving an example, okay? The given differential equation is d square y minus dy dx minus 2y equal to 0. This is a second order differential equation. The highest power in which it was differentiated is actually 2. That's why it is second order. D square y minus dy dx minus 2y equal to 0. Actually, this can be written as simply y double prime minus y prime minus 2y equal to 0. These two here are the same because y double prime is d square y over dx square and y prime is dy dx. Okay, but I prefer this one if we are trying to solve a second order differential equation. So for the meantime, I will forget this one. But they are the same. Under the concept, the solution is actually y equal to k e raised to mx. Okay? Okay, let's try to take the first derivative. The first derivative is dy dx equal to the right hand side. It will be constant times an exponential function, so it should be k times e to the mx, okay, times the derivative or differential of the exponent, which is m. This is actually times 1. Okay, because we are taking the differential with respect to x. M times 1 is just m, so we could remove this 1, or this is just simply m. Meaning dy dx is equal to km e raised to mx. Taking the second derivative, d square y over dx square, we'll take the derivative of the first derivative. That will be the second derivative. That's why it is second order, right? So this should be km e raised to mx, okay, times m, okay. M times m is actually m square. So what comes out for the second derivative is km square e raised to mx. Then we will try to take this value of y and this value of dy dx and this value of d square y over dx square. We place it on the original second order differential equation. So I place it here substituting. It will be km square e raised to mx minus km e raised to mx minus 2 times y, which is k to the mx equal to 0. If you try to notice it, in each of all the terms, there is a common factor k times e raised to mx. So we will multiply all the terms by the reciprocal of this to eliminate the common factor. So all the terms should be multiplied by 1 over k e raised to mx. And if we try to expand this one, actually this will be gone. Right? If we try to expand. second term, it will just be simply, this k will be gone, e to the mx will be gone, right? And for the last part, this will be gone. If we try to expand. So what comes out is actually an m squared minus m minus 2 equal to 0. This is a quadratic equation. This part of the solution is the algebra portion. That's why I annotated on the right hand side, upon the so-called expansion, what comes out is a quadratic equation that is involving m squared. M squared minus m minus 2 equal to 0. In here, we can solve for the value of m by using the quadratic equation, or by using, try to factor out if it is factorable by inspection. I think it is factorable by inspection. The middle term is plus m minus 2m, so it will be minus m. And the pure constant should be a minus 2. A minus 2 plus a plus 1 is actually a minus 2. So the possible linear factors are actually the quantity m plus 1 times the quantity m minus 2 equal to 0. And under algebra, if you try to equate each factor to 0, we can solve for the factors. M plus 1 equal to 0, m1 now will be equal to minus 1 after the transposition. M minus 2 will be equal to 0, therefore m2 after the transposition, m2 will be equal to plus 2. So what comes out for the value of m1 and m2, this is minus 1 and this is 2. And they are not equal, right? And minus 1 and plus 2 are both real numbers. So this falls under case number 1. Okay, so the general solution now will be equal to k1 a raised to m1 is actually minus 1 times x. It will be just simply negative x. Plus k2 a raised to m2. What is m2? 2 times x, the exponent of p will be equal to 2x. So after the substitution of the value of m1 and m2, this is now the resulting general solution. That is y equal to k1 e raised to minus x plus k2 e raised to 2x. That's it, guys. It's easy to solve a second order differential equation. Okay? You just let the substitution y equal to k raised to mx, take the first derivative, then take again the derivative of the first derivative. What will come out will be the second derivative. Take these three substitutions, put it back to the given second order differential equation. What will come out will be a resulting quadratic equation involving the unknown values of m1 and m2. After the computation of the value of m1 and m2, okay, just recall the formula on how to take the general solution of case number 1. It will be y, it will be k1 e raised to m1x plus k2 e raised to m2x. And after the substitution, the final general solution will be y equal to k1 e raised to minus x plus k2 e raised to 2x. It is easy. Okay? Okay, that's it, guys. For those who are taking up engineering and having the subject differential equation, this is for you guys. So if you want to like it, please click like. If you want to share it with your friends, if they are studying differential equation, please click share. And if you want to learn something under the subject matter differential equation, okay, please click subscribe. You can access my channel and all the topics are there. Good afternoon, Los Angeles.